My name is Marlene, and yes, this is my talk, Elephants, Ibises, and a more Pythonic way to work with databases. So I'm going to just do a quick introduction of myself. I am from Harare, Zimbabwe. Zimbabwe is a country in the southern part of Africa. We have lots of elephants there. I was going to pull up a picture of me with the elephants, but because of the time, I won't. But I love elephants, and I'm also a developer advocate for Voltron Data, and Voltron Data is a company based out of California. I work for them remotely. Before Voltron, I was working for NVIDIA as a software engineer, but then decided I wanted to try out developer advocacy. So another thing about me is I'm the vice chair of the ACM practitioner board. So the ACM is the Association for Computing Machinery, and I just joined as the vice chair, and I'm also very involved in the Python community globally. So I was on the board of directors for the Python Software Foundation, and the PSF is the nonprofit behind the Python programming language. So if you're interested in the PSF as well, just Google python.org and look for the PSF tab. And if you have any questions after this talk, or you would like to connect with me in any way, I am on Twitter, Marlene_ZW, so please feel free to tweet at me. I'm also on Blue Sky, just Marlene there, and then my website is marlenemhangami.com. So, for this talk, like I mentioned, I'm a developer advocate, and I usually, whenever I travel, I usually go to tech conferences coming from Zimbabwe, and it takes me usually over 13 hours to get anywhere when I travel. And so I try to kind of use the time whenever I go to a specific city and explore the city after the conference. So even when I was coming here to Malaga, I decided I wanted to explore, and one of the things I love is to check out the art in a city. And for exploring, since I am a software engineer, since I'm a Python developer,
Sorry to interrupt. We are having some issues with the sound.
Okay.
So our troubles are not over. We're interfering in the room next door. So okay. I'm going to ask you to use the mic. Is that okay for you?
Yeah.
I'm so sorry. Can we remove the headset? Okay. Sorry about that.
That's okay.
Yeah, you need some
correction. Great day for a talk, right? Okay. So, like I was talking about art, so this is going to be, there's going to be a lot of art in this talk, and like I said earlier, one of the things that I like to do is explore the art in a city. So even before I came to Malaga, I was just like, okay, let me go ahead and look for some data on the art that's available in Europe and in Malaga specifically. And one of the sites that I used to do that is this site. It's called the Web Gallery of Art, and it is a website that has lots of information about the European fine arts, decorative arts, and architecture from the 3rd to the 19th century. So it's very much about like Renaissance art, and there's a section just for Spain as well. So it's a very interesting website that I found, and they had some good data there. So I want to go ahead and look at some code and show you how I got some information about the art in this city using that website. So the first thing that I did is exploring, so this is my terminal. I have a purple theme, I love that. And the first thing that I did was I imported pandas, and for that I read in, so on the websites they actually give you either a TXT file or an Excel file that you can use to be able to read in the data. So I just went ahead and I used the read Excel function to be able to check out the initial data. So let's go ahead and run this cell and see what we have. So we have a table that they provide, and you have the name of the author, you have the date the author died, so that's useful information. You have the title of the art displayed at this specific gallery by the author, and you have the style of art they have, as well as the specific location where the art is located, the URL to an image of the specific painting or art or whatever it is, the type, and the school. So like one of the cool things is from this data, I can actually tell whether the art has German style or Spanish style or whatever style of art. And so the first query that I decided to do was to check which European city has the most Spanish art. So does anyone want to guess right now which European city has the most Spanish art? Who wants to take a wild guess? Yes. Paris? Okay. Anyone else? Madrid? Okay, let's see. So this was I went ahead and I just used the contains method to check for the Spanish school, and then I looked for the location and did a group by. So we're grouping the art by where it's actually located, this column here, and we're sorting the values by how many titles, so how many pieces of art are in this specific location. So let's go ahead and see what the results are there. And you were correct, Madrid was correct. Madrid actually has, in this specific data set, it shows that Madrid has 361 pieces of Spanish artwork. So this is Spanish style specifically. A second thing that I decided to do as well was I wanted to see what art was specifically located here in the city of Malaga. So to do that, I just used, I specifically searched for the location, any string, in the location column that had Malaga in the string. And so when we run that, we do get several pieces of art. I just am taking the head function, so I'm getting the first 3 rows, and we have some art that's located here. And so I do want to, so as you can see, the data also provides us with the author name. So this is the artist that created some of these paintings. And does anyone want to guess who the most popular artist in Malaga is? Do we have any guesses of who is most popular? Yes. Picasso? Okay. Anyone else? Any other guesses? In Malaga specifically, so this is just who has art hosted there. And also, the data set is limited. I'm not sure, it's probably not exhaustive. So let's see if Picasso is the right choice. So let's try and run that. Oh, and according to this, they only have 4 titles that they searched for Malaga. And, I cannot pronounce this. Antonio is the most popular artist with 4 titles. And again, like we can see here, one of the things is that with some data sets, when the data set is smaller, it's going to be limited in terms of the amount of information that's there. So that's one of the disadvantages of working with the smaller data set like this one. So I just want to give us a second to just go ahead and take a look at what the art actually looks like. So I just made, ran some requests to be able to grab the art directly from the website. And here's an example of some of the art that's available in Malaga. This is going to be located at the Museo Carmen Thyssen in Malaga. And it's by Abraham Blomart. So if you want to do something after the conference, feel free to go to this museum. So another place that I am going to be traveling to soon is New York City. And here we go. And so, a similar thing, when I go to New York, I want to explore the most culturally exciting places in New York. And one of those places is the Met. Has anyone heard of the Met Gala before? Here on the screen we have A$AP Rocky and Rihanna. If anyone is a fan of these two, I am. And the Met also is not just a place for people to dress up in fancy clothes. It's also an art museum. And the Met has a lot more data. They collect the data, and they also have the pictures, images of the art that they carry hosted online on their website. So as you can see, they also have art from all across the world, and that's something that's very cool. They have over 450,000 works of art just hosted on their website, and some of the art is also not present on the website. So when we are thinking about looking at a data set like the MIT data set that's much bigger than the first data set that we looked at, we have to think about some things, or there's some things that we need to consider when we're working with larger data sets. So the first thing is that the data is big. And so for the MIT data set specifically on Kaggle, it's actually hosted there, and the data set is 36 gigabytes in size. So this is a really big data set. You have the images as well stored there. And a typical laptop actually has about 8 gigabytes of RAM in memory. And this is, this is actually quite a lot over time. The amount of RAM in our laptops has been growing. But if you are someone who, say for example, in our initial example, I went ahead and thought the first tool that I'm going to use is Pandas. But, Pandas is a really popular library, and people in the Python community love using Pandas, data scientists specifically as well. And even though Pandas is a great tool and it's very popular, it really struggles when you are working with larger data sets. And one of the reasons that Pandas struggles is because when you're loading in data into a Pandas data frame, it's going to load all of the data into memory, so into your RAM. And the creator of Pandas actually says that to be able to analyze data sets that are large, you want to have at least 5 to 10 times as much RAM in your machine as the size of the data set. So in our machine, in a typical machine, in a typical laptop, you're going to have 8 gigabytes of RAM. And so if you have a 36 gigabyte data set, that is going to break Pandas. And so as you can see on the screen, the Panda is having a breakdown there. And so even though we love Pandas, what do we do when we have data of different sizes and Pandas breaks? Well, something that we can do is we could use database engines. And one of the great things with database engines, particularly database engines that use SQL, is that they're built to handle data of any size. They're actually built to handle big data. So we can think about a database engine like, for example, MySQL or Postgres. We can even think of Google BigQuery. Just a number of different databases that you specifically use SQL. We can think of those as an elephant. And as you can see on the screen, the elephant is much happier carrying this box of CSV files or whatever files, because an elephant is much larger and stronger than our panda friend in the last screen that we saw. And so even though SQL is built to be better at handling large data sets, not everyone likes writing SQL code. And personally, I do not like writing SQL code and will avoid it as much as I can. And so what happens to data scientists who want to use something like Pandas and are used to using Python code when they're working with large data sets? Well, one of the tools they can use is Ibis, and that's what I'm mainly here to chat to you about today in this talk. And we can think about the library Ibis like an actual bird. So Ibis, what it does, it's a Python library, and you're able to write Pandas-like Python code, and it sits on top of your database engine, so you can choose any database engine of your liking, and then you write Python code, and it generates SQL and sends that to your database engine. So that's what it's kind of doing under the hood. So basically what it does is that it has lazy evaluation, so it actually doesn't pull your data into memory like Pandas does. It just uses the backend to do the heavy lifting for you because it's generating that SQL. And so Ibis is a really good option for people who like using Pandas. Here's an example of some code in terms of what Ibis looks like. As you can see, it's pretty similar to Pandas. It's not exactly the same as Pandas, and it's not as feature-rich. That's one of the criticisms, I would say, because it's a fairly new project. It's open source as well, but it's fairly new, so they're still building out some of the features. But it's going to allow you to compile to SQL, and anything that you can write with the select statement in SQL, you should be able to do in Pandas, in Ibis, but with sort of this Pandas-like syntax. So one of the examples I'm going to give today is using Ibis on top of Google BigQuery locally on my own machine. And the Met data set is actually hosted on BigQuery through their public dataset program. And they have 200,000 pieces of art hosted on the public datasets platform. And one of the awesome things as well is that this dataset is hosted remotely. So instead of having it just on one person's computer, lots of people around the world can access it since it's hosted in the cloud. And the dataset is also going to be consistently updated because it's being hosted by Google. Whereas for me, if I just have the data on my own laptop, I'm probably not going to update it. So again, BigQuery, if any of you have used BigQuery, uses SQL to query the data set. So if you're just going onto the BigQuery site and you're trying to query your data from BigQuery, then you're going to have to use SQL there. And like I mentioned before, we are trying to avoid using SQL. So I'm going to go ahead and show you some examples of what this looks like locally on my machine in my code editor. So let's go back to VS Code. And here, let's start by exploring the dataset with BigQuery. So we're going to start off by importing Ibis. And then we're going to set interactive mode to true. And all interactive mode does, it allows us to be able to visualize the data in a table much easier and in a clearer way. And then we are going to connect to Google BigQuery. So this is pretty much what you need to do. So if you have a project on BigQuery, you want to go ahead and put in your project ID. You also want to put in the dataset ID. So I'm connecting to the BigQuery public data Met dataset. And obviously for the project ID, don't use Marlene's project, use your own project if you decide to do this. So we can this cell, and that will literally connect to the project and this specific data set on BigQuery. So another thing we can do is we can go ahead and list the tables that are hosted there. We have an images table, an objects table, a vision one as well. And then the vision API is very interesting for people who want to do machine learning and sort of generative AI work. That has some very cool functionality that you can also take a look at. And then let's also look at the columns that are available. We're going to load in. So this line here is specifically loading in the objects table. And it's just going to give us some information about the specific art pieces that are available on BigQuery. So we have all of these columns here. We have the title of the column, which culture it came from. You can see because this is hosted by BigQuery and it's from a maybe more established institution, it has a lot more data on the website. You also have the artist name and artist end date. I think that's the date the artist died. I'm not sure, but it's something like that. And so very comprehensive information, lots of columns here. And so we are going to go ahead and find out. So can we get another guess in the room? Which country do you think has the most art exhibited at the Met Museum? Who wants to take a guess? Egypt? Egypt? Okay, that's a good guess. Any other guesses at the Met? It's in New York City. America might have the most. Okay, so let's go ahead and run the query and see. And we're sorting it here. We're just using a sort by the title to be able to get it. It is taking a bit longer than. Hopefully it doesn't break. Hopefully it runs and works, but I'm doing, maybe it's taking a long time because I'm doing a group by on the country column. I'm counting the number of titles that a specific country has in the Met, and I'm sorting that by the number of titles as well. So if this runs anytime soon, hopefully we will have an answer to that question. I wonder if I just stop it and get the head.
Is the data already fetched from the...
It should have already, it shouldn't take this long, I'm not sure why. I don't know if I didn't run something before. But let me go ahead and just call the head. So I will get the top 5 and see if that will make it shorter. Let's try that. And hopefully it'll work. Well, today has been a lot of errors anyway, so we'll see. I don't know why it's taking so long, but hopefully it'll be done at some point. And unless I'm not connected, I don't know. But hopefully it should run and give us an answer at some point. But the second question that I will ask while it's running is whether we think that are there any Spanish artists that actually have art hosted at the Met. I also think, sorry. So for some reason it's not, okay, I'm just gonna stop it. I'm gonna try the second one to see, or I'm just gonna run this here and see if this is working. And if not, I will just talk through the code and then we'll just move forward because, yeah. Anyway, it's fine. So another thing that we can do as well is we can use a similar code that we used with pandas. We can use it with Ibis as well. And when we do that, because it's pandas-like in its structure, you should be able to, in an ordinary day, this should run and shouldn't take as much time. I'm not sure if it's maybe because there's a delay in my connection with BigQuery, I'm not really sure. But yesterday it was running fine. And when you connect to BigQuery and you're doing these things, one of the advantages of this is that if you have a smaller data set that you want to test your data on, you can then upscale. So if you have a small data set and then a very large data set, but you want to run the same commands, you can really easily do that with Ibis. And you're able to use similar code for a prototype, maybe on your local machine, and then scale that up to the cloud with something like Ibis. And for some reason it's not working, and I think my time is almost up. So I'm just going to go back to. Let me just try and rerun this one more time in case that helps. It's been an interesting day. But I will just set this one in the side. Let's go back to the slides. Okay. Ideally, when the code is actually running correctly and the connection is working, for some reason it isn't today, but when the code is running correctly, with the right tools, big data should essentially feel small. And you should be able to run code that you would usually only be able to run with SQL. You should be able to do that on your local machine and in a pandas-like format. So some of the tools that I enjoy using for big data in Python are Ibis. There's another tool called Polars, and Polars has a Rust backend, so it's very efficient as well. There's also Apache Arrow, which is an amazing tool for converting. If you have a large data set and then you want to take that data set and make it smaller, you can use Apache Arrow to be able to do that. And it will compress that. Maybe you want to change your CSV files into Parquet. Apache Arrow is an amazing thing to be able to do that with. And there's also DuckDB. So there's been several talks earlier before on DuckDB, and it's a really efficient database engine as well to use. Now, if you want to try Ibis out, this is a great place to start. So you can go ahead and set up your Python environment. You can run pip install, and you just run Ibis framework. But in this specific one, you can choose whichever your backend is that you're going to use to be able to install that. If you just run Ibis framework, it will install, and it will run with the default backend, which is DuckDB. And in this example here, we are using the SQLite backend, and that should work as expected. So that is the end of my talk. I'm just going to go back and see. No, the code is still running. I don't know what's going on. But ideally, it should work. But if you do have any questions, I did a workshop earlier at this conference, and I made a website for the workshop, actually trying out Ibis. And hopefully, if you try it out, it will work on your machine. And you can just go ahead and check out the website that I made. If you want to chat to me, I'm Marlene@voltrondata.com. I'm also very active on Twitter, so I'm Marlene_ZW there. But thank you so much for listening.